Algebra 2, section 7-7, base E and natural logs. What's E? E is a letter that represents an irrational number and it is 2.71828 ... It goes on. It's an irrational number, and it is the natural base. And so let's look at some stuff using E. So if I have f of x equals e to the x power, this is continuous exponential growth. And if I have f of x equals e to the negative x, then I have continuous exponential decay. Now, we're going to look at these guys here, and we're going to say the inverse is a natural logarithm. So remember, the inverse of an exponential function is a log. And so the inverse of an exponential function that has the natural base e, then we have a natural log. So this is what that looks like. We just have log base e instead of base 5 or 10 or whatever of x. If we, instead of writing log base e every time, we just write ln of x. And so ln of x means log base e of x, just like the common log was log base 10 of x. And so we just write log of x. Now we can write natural log instead of log base e of x. So here's an example. Natural log of 4 equals x. We can rewrite this as, so I take that x, jam it down over there, the 4 comes out, and so I have e to the x power equals 4. So we just have that e down there at the bottom. All right, so let's do some examples of this. Where we are going to solve these equations. Kind of. Are we solving these? Rewriting this as a, we're taking an exponential equation and we're rewriting it as a logarithmic equation. That's what we're doing. We're not solving. Okay. So what we do here is, remember, we take this 8, jam it up in there, the x falls out, and so I have log base e of 8 equals x. The x flops out over there. So instead of writing log base e out, I'm going to write natural log of 8 equals x. We're going to do 2 more. E to the 5th power equals x. So again, take that the x, put it right in here. 5 flops out over there. Log base e of x equals 5, or natural log of x equals 5. Okay, so now you guys do one without me. E to the 7th power equals x. So go ahead and pause if you need a second, get that one done, and then we'll look at it together. Go. All right, so this one, x goes in there, 7 drops out. I'm going to have the natural log of x equals 7. All right, let's move on to some more stuff here having to do with natural logs. If I have the natural log of x equals, or is approximately 0.7741. Now, if you're looking on the calculator, just as a little aside here, you can see you've got natural log button right here, and you've got e to the x power right here. So your calculator, if you've got one of these guys, should have natural log and base e stuff on it here. If we need that. I don't know if we'll need that today or not yet. We'll see. So we're going to rewrite this as an exponential function. So we're taking it now from the logarithmic function and we're rewriting this in exponential form. So this is going to go up here, and so I've got e to the 0.7741 equals, and the x falls out onto the other side. So let's see if you can rewrite natural log of 10 equals x. Rewrite this in exponential form. Okay, let's see how you did. That x goes there, 10 drops out. I've got an e to the x equals 10. Okay, now we're going to do a little more work to these. We're going to simplify to a single log. Here's our example. I've got 3 natural log of 10 minus natural log of 8, and I want to simplify this to a single log. So just because it's a natural log doesn't mean it's really different than any other logs we've used. So we can still use all of the ways that we combine logs from before. We're just using a natural log. It's just log base e. So we can use the power property, we can use the quotient property, we can still use those things to combine these. Just because it's natural log, you don't need to be scared. So I'm going to take this 3 and I'm going to put it up here. So it's natural log of 10 to the third power. And then I also have this negative here, which means this 8 is going to go down to the bottom of the fraction. So I'm going to have natural log of 10 to the third power divided by 8. So that's how I would do the quotient property here. And so I'm going to keep working on this. 10 to the third power, 10 times 10 is 100, and then times 10 again, that is 1,000. Okay, so now I need to go, okay, does 8 go into 1,000? So we can, if we're not totally sure, we can say 1,000, 1, 2, 3, divided by 8, 125. Great. So I've got natural log of 125. So we could be done here, but we're going to simplify. We're going to kind of reduce this all the way down. So 25, that is 5 times 5, which is 25, times 5 again. So this is 5 to the third power. So let's rewrite this as natural log of 5 to the third power. And then we'll take this third with the product, with the powers property, and bring it over here. 3 natural log of 5. That's the final and best answer right there. Let's do another one. Six natural log of 8 minus 2 natural log of 4. Okay, so there are 2 different ways, well, probably more than that, but there are a couple ways that we can go about handling this. So let's start, though, with bringing the 6 up here and bringing the 2 up here. So we've got natural log of 8 to the 6th power minus natural log of 4 to the 2nd power. Okay, and this is kind of a step that we kind of skipped in this last one. I just did the subtraction, put that there in the bottom. And so let's do that next. Natural log of 8 to the 6th power, 4 to the 2nd power, and we are going to get back to this in just a moment.